Okay, so I believe we are starting out. Are you sure you want to stop the
Ah,
broadcast? Oh, yeah.
yeah,
Okay.
there we go.
So don't stop the broadcast. Okay, so here we are. Here we are. Um, Let me share my screen. Window. Okay, off to a little bit of a rocky start. All right, so let me back up. So welcome to the panel discussion for graphical user interfaces for R. Graphical user interfaces are abbreviated GUI and pronounced GUI. I'm a big fan of GUIs because I've worked with so many professors that only occasionally get data sets once or twice a year. That's not enough practice to be able to maintain their skills with a programming language, but it's fine if they're using a GUI. So here's an example shot of a GUI. Most of the GUIs you see today will look similar to this, where you have menus across the top, some variables to drag into various positions, either in the graph you're going to make or the analysis. And when you click run, you get your graph or your analysis. Where they differ a lot is in the resulting code. So this is the R code behind the scenes that created that graph. This happens to be ggplot code, but some of the GUIs you'll see today will use R's base graphics. Some of them will use lattice graphics and others will use custom code. Okay, so some of the key features to look for in a GUI is, let's see here. Just realized it's not doing that. Okay. Some of the key features are that they're easy to learn and use. And of course, they mostly all are easy to use via the GUI. How hard they are to use via code depends on their perspective. Sometimes they have a very simple text editor, and other times they have a very powerful integrated development environment. So you've got a trade-off between ease of use and power there. Other aspects to power is looking for data wrangling capabilities. Some of these have a lot of data manipulation ability, and others refer you out to the database or spreadsheet to prepare your data before you bring it in. When it comes to visualization, as I mentioned, they use various methods behind the scenes. And for analysis, some of them differ quite a bit because some will do statistics, perhaps only frequentist statistics. Others will do frequentist plus Bayesian. And some focus just on machine learning or artificial intelligence. And some will do all of those. So when it comes to our code, we want to be able to see the code that it's showing us, so that it'll hopefully be able to teach us how to program if that's what we want, or we want our students to learn. Then we also want it to be extensible. So if we've got our own R code, we can add that to the menu. So when someone says you can't use a GUI for data science, to them I respond that they just need to learn how to add their R code to the menus. Hopefully you can see publication quality output from the GUIs. Some of them do this via cut and paste into word processing. Some do it via LaTeX, and others leave it for you to do as additional steps on your own. When it comes to reproducibility, pretty much all of them will allow you to reproduce what you've done using either menus or code, and they'll save all those settings. Some of them will let you do both. When it comes to package management, hopefully if you do a bunch of work and you try and redo that work 5 years from now, if anything changed in R, or anything changed in the GUI, for some reason your code is no longer running or your menu choices are no longer running, then hopefully you can go back in time, just download the version that it worked in, and it should work because R is oftentimes integrated in with these GUIs, but not all of them. And hopefully we want to get our software free and open source. So here are a bunch of other attributes that GUIs have that we're not going to have time to go into. But if you go to that link up there, I've got about a 20-page review of each one of these GUIs and a couple of others that address all of these attributes. Tomorrow, Thursday, at the same time, there's going to be another talk on our GUIs. And in particular, the Mayo Clinic is going to be making a fairly major announcement. So these are the GUIs and the presenters, and I'll be introducing them one at a time. And I've got a link here. This is the permanent link to the comparison article I mentioned. Okay, so our first speaker today, let me back up here and stop sharing. Okay, our first speaker today will be Aaron Rangel, the co-founder of Blue Sky Statistics.
Thanks, Bob. Let me go ahead and share my screen here. It should show up in a couple of minutes, or a couple of seconds rather. So at Blue Sky Statistics, we've tried really hard to create an exceptional user experience for both an entry-level statistician or data scientist or machine learner, as well as for a sophisticated R programmer. So you're looking at the application, as Bob talked about. We offer a comprehensive set of menus that you can access for right from data preparation to analysis. You can bring up each of the dialogues by just clicking on the icon here, and then you can drag and drop variables and select options for the analysis that needs to be performed. We've got a rich set of visualizations incorporating popular packages, a rich set of machine learning, model tuning, model fitting, model scoring capabilities as well. So on the left-hand side of the application, we give you the ability to open data sets, and we show you all the open data sets here. You can open up multiple data sets in multiple formats, and the data grid is completely interactive. So if you wanted to go in and change a value here, you would just type in, and those values go in effect immediately. We support all the typical R data types, obviously, as well. So in addition to the data view, when you click on a data set, you see by default the data view here. I'm moving my mouse a little bit so you see that that's towards the bottom left-hand side. But we also have a variable view. So clicking on the data set, you see the data view, which is our interactive data grid. But we also have a variable view, which gives you a ton of your typical data manipulation commands accessible at your fingertips. So for instance, if you wanted to go ahead and make year a numeric, you could make year a numeric. It's currently a factor. You see the levels there for year. If you wanted to go in and add a level to a factor, you could do that easily using the GUI as well. So on the right-hand side, you have the output of the analysis, and we give you the ability to open up multiple output files. You can browse the output, obviously. We make it as rich as we can in terms of the interactivity. I'll talk a little bit more about it, as well as the way the tables are laid out. You typically will see a format that's more popular with the academic journals by default. So let me go ahead and open a new output window and do some simple analysis so you see the application in action. Let me go ahead and run a factor analysis here. So I'll click on the analysis tab, click on summary, and let's run a frequency. So let me run a frequency of species, island, and perhaps sex. I will drag and drop those variables, and I will click the execute button, and you will see the output here. So as I said, we've really invested a lot of time in making this output very, very interactive. If you want to see the R code, you click this button here and we'll show you the R code. So we've taken a lot of trouble to use tidyverse, popular R functions, popular R packages as well, and show you this format in the code in a nicely formatted way. If you want to see the dialogue in its original state that was used to create that output, moving towards reproducibility, you certainly can do that as well and see all the options. In this case, I don't have too many options on the dialog, but if I wanted to remove sex and rerun the analysis, I could do that as well. Now, all of this output can be very easily be copied into Word. This is a simple table, but we've done a lot of work to handle complex tables and pasting them into Word well. I think I have an example here of some more complex tables. I think this was the table that you pasted. I could have pasted into Word, but here I have some more complex and long tables as well. Again, if you want LaTeX, we can give you LaTeX. Just set an option and you will see the LaTeX. And I've got the LaTeX equivalent of this available here that you can copy and paste as well. Going further, if you're more sophisticated and you want to go and see the R code and you want to change the R code, you can do that as well. I'm going to add sex back again just to keep things simple. And you get a message saying that, hey, the change you made will not be reflected in the dialog. We're going to lose the binding to the dialog, and you can rerun that R code as well. So let's go ahead now and create a slightly more complicated graph. I'll go into scatter plots. And let's say I want to generate a scatter plot of bill length versus body mass. And let's say I want to color the dots by the island that the penguin comes from. I will go ahead and say I want a smoothing model for my scatter plot. Let me go ahead and set some facets here as well. Say I want a row facet for species and a column facet for sex. Let me go ahead and execute this dialog, and let's see what we get. So what you're seeing is a pretty, advanced scatter plot, again, created in seconds, at your fingertips. Now, I'm kind of lucky here because I had just 3 locations that these penguins come from, or rather 3 species of penguins. Just say I had 100, I would argue that this chart wouldn't be that useful because I'd have 100 different species or 200 of these graphics munged in the small area. So to solve that, to make it really easy for the analyst, you can go in and split or group by factor level. So I'll go and set a split here, and let me split by species. And as soon as you split by species, any graphic or any analysis is repeated for every factor level. So just to show you, it's not just the graphs. We'll do any analysis as well. If I want to go ahead and run the one sample t-test and compare bill length and bill depth, I will now run this analysis automatically for each level of the factor variable species. So for each species, I will have a separate one sample t-test. Here I have the results for species equals. I'm not going to pronounce that. I'll just highlight that for you. I'm not an expert on penguins at all. This is the other species, and I have the third species. Again, if you had 100 species, you would get 100 scatter plots here, or 100 one sample t-tests. Again, really easy to see the code. Let me show you that with the scatter plot because that's more meaningful. And you can change the code here as I talked about, and you can even recall the dialog and rerun the dialog. Let's say if you don't want it colored by island, you can go and rerun that as well. Now, again, going up the ladder in terms of sophistication, we have a fully functional R IDE here. Okay, I'm going to open it up and I can make it larger. I can make it smaller. And this is not just for you to paste code from, a discussion group or a Stack Overflow, but you can also run this line by line. And you can see here there's some pretty sophisticated syntax. You can use the execute button or you can do Control E, and we automatically go to the next line of our code. So we've got a built-in parser here that understands our code. We will do Python again in an upcoming release. And
Okay,
run this.
Aaron,
Yes.
thanks very much for that presentation. So it's time to move on to the next one.
Okay, I don't get a minute. Okay,
sorry, did you not hear the 1-minute beep?
No, I didn't. Why don't you give me I just want to make 2 points. So what's really important is with the output, you can save it to our Markdown format. You can save it to a Blue Sky statistics format. So all these outputs can be given to people running our studio, and they can have the exact same output that you see here. You can also give this Markdown to someone running Blue Sky statistics, and they'll have the same interactivity. Bob, since I'm out of time, I'll leave it back to you. There's
Great.
certainly a lot
Thanks.
more that we can talk about.
Thank you. Let's see if you could stop sharing.
Certainly.
Okay, our next presentation is going to be by Jonathan Love, who is a software developer and researcher at the University of Newcastle. And we're using a video for his because he was up at 3 a.m. yesterday doing another one of these for us from Australia. Let's see, and that is the Jamovi one.
So I'm obviously going to spend most of my talk today demonstrating Jamovi, but before we get started, I just want to prime you in thinking about Jamovi in a particular way. So yes, Jamovi is a fully self-contained desktop application, but it's also a web application accessible from the web browser. So rather like our studio, we come in 3 flavors, a desktop version, a server Docker container version, and a public cloud version. And so the cloud version is actually running at cloud.jamovi.org. So if you get bored during this talk, or perhaps even interested, you can head over there and take a look. I'll be demoing the desktop version today, but I'm actually far more excited about the web version. To sort of give you a quick taste of what we're doing with the web version, here's Jamovi embedded inside an R Markdown document. And here it is embedded inside JTOS, a psychology experiment web service. And so a lot of what we're on about is facilitating these interactions. But the emphasis of today's session is on being a GUI for R. So I guess that's what I'll talk about. So this is what Jamovi looks like. You'll notice that we're very unashamedly a spreadsheet. But as you'll see, what we've tried to do is we've tried to make it very easy to mix and match spreadsheet and R programming concepts. And that'll hopefully come clear to you as I demonstrate. So it's probably easiest if I start with a example data set. And so these tabbed sort of interface. So, you know, we've got variables tab, which gives people an overview of the columns in their data set. We've got the data tab, and this includes a range of data and transformation type procedures. So you can recode data, you can compute new variables, you can even filter out rows and things like that. Coming over to analyses, we've got a range of analyses available. So under exploration, of course, we've got descriptives, we've got t-tests, ANOVAs, under the linear regression, frequencies, factor analysis, etc. And of course, if Jamovi is missing something you need, you can always come over to the Jamovi library and find it there. So the Jamovi library is a bit like CRAN or CRAN for Jamovi. It contains a whole list of additional modules that you can install to provide Jamovi with more features. So what I'll do now is I'll install this one here, the RJ editor, and this allows us to run R code directly inside Jamovi. And so you'll see now that's complete. It's created this additional icon here. But let me come back to that. First up, I just want to run some descriptives. And so what I can do is I can just pop things from the left over to the right like this. Maybe I want some frequency tables. Maybe I want a box plot or box plots. Yep. Really, this is more of an ANOVA data set. So maybe let me run one of those. And again, I'll just pop things from the left over to the right. Maybe I'll plot some estimated marginal means while I'm here. But the order here is not quite right, so let me just reorder them. Yep, that's looking good. So now I'm here, let me just show you our first R trick. What I can do is I can come up here to the syntax mode, and you can see what that does is it creates this little block of R code at the top of each analysis. So I can take this, I can copy it, and then I can come over to RStudio, and you know, I can paste it in here like this, and let me update the data set we're using. And so if I run that, you'll see that I get exactly the same analysis and the same plot and everything. So yeah, so that's quite nice. So we've tried to make it really easy for people to be able to run their analyses and then move over to R if that's what they're wanting to do. So that's the syntax mode. Lastly, down the bottom here, I've got this option to save the residuals. So I'll save those. If I come back here, you'll see that this has created an additional column in the dataset called residuals. What I'll just quickly do is I'll come back up to these descriptives and let me pop these out. And then I'm going to pop the residuals in there like that. Now let me come back down to the ANOVA. Now let's think about it, right? This is a spreadsheet. So let's have a think about what needs to happen if I change this value here. So what I'll do is I'll just change this value to something silly, 1,000, so that the change is really clear, and hit enter. And so hopefully what you're seeing is that the ANOVA is updated. And then because the ANOVA updated, it writes a new set of residuals to this column here. And then because the residuals changed, the descriptives responded to that. So the descriptives have recalculated, and yeah, you can see row 9 corresponds to this outlier here. And of course I can come back down here, I can undo my change, and we're back the way we were. So that is the spreadsheet side of things. Now what I want to show you is the R side of things. So I'm just going to start with a new data set. And the first thing I'm going to do is I'm just going to delete these 3 place marker columns. And then I'm going to come here and I'm going to run RJ editor class. Let me just shift this over here and shrink this up. And what I'm going to do here is I'm just going to read in a data set from the internet using the Rio package. You can probably tell I've got one of those mechanical buckling spring keyboards. Okay, and here we are. We've read in the cars data set. And so, you know, I can go on and I could run a linear regression if I wanted. Maybe I'll look at miles per gallon as a function of horsepower. But of course, I can run exactly the same analysis in R. So let's do that now. So again, let me just bring miles per gallon and horsepower across. And then I'm going to go model. I'll define my model using the LM function. What do we say? Miles per gallon as a function of horsepower. And let's run that. And so when we do that, we get this 30.08989 for the intercept, and we're getting the same results. Actually, let me put on the show code and output so we get the code as well. What else can I do here? Oh, well, maybe I want to save the predicted values from the model back to the data set. If I run that, you can see that's what we're doing there. And, you know, we can do any sort of R stuff we might want to do here. So maybe we want to plot the predicted values against the residuals of the model, like so. And that's what we get. But yeah, but that is the sort of the R side of things. Hopefully you can see that we've tried to make it as easy as possible to be able to mix and match the contents from both the spreadsheet and from R. And that's basically my talk today. If you want to learn more about developing modules for Jamovi, we've got great tutorials at dev.jamovi.org, and we've got a great community, so we'd love for you to come and join us. Thanks.
Thanks, Jonathan. I don't know if any of you caught the fact that the colors used on their icons match the default colors in the graphs. I thought that was a really sweet little touch. Okay, the next speaker is Erik Jan Wagenmakers, who's a Dutch mathematical psychologist and professor at the methodology unit in the Department of Psychology at the University of Amsterdam. Take it away, EJ.
Thanks, Bob. I'll share my screen. And before I start the demo, I will show a few PDF slides. So my demo will be about JASP, a brief note on its origin. The program, basically the idea for the program started back in 2010. And the idea was to construct a kind of Bayesian SPSS. So it's no surprise then that some key features of JASP actually resemble those of SPSS. JASP has a few core design principles: simplicity, direct feedback, and progressive disclosure. This is the JASP team. Some people work on JASP full-time. Most only work on JASP for half a day a week or a day a week. But I'm grateful for all their efforts throughout the years. And a little bit of a commercial here. We do teach an annual workshop with JASP on Bayesian statistics. So it's a hybrid event, August 29th and 30th, together with Richard Murray. And more information you can find on our website. So on to JASP. So JASP, we do Bayesian analyses. We also do classical analyses. So both, actually. So on to the program. I've already opened it. We have a data library. And from that data library, I'm going to pick my favorite data set, a regression data set that shows you movies by Adam Sandler. So you see the movie title, box office success of the movie, freshness ratings on Rotten Tomato. So we can examine whether movies that earn a lot of money at the box office are rated to be better movies. So we can now go to descriptives and we can say examine the freshness scores. Immediately you see here that a table is being populated. It's an APA style table. If we wanted to, we could copy it or we could copy the LaTeX code. And what I particularly like is that we can add notes. So we can say, for instance, this is a great table, or something more informative about why we did a particular analysis or what the variables mean. Of course, we could adjust the table if we wanted to, but here I just wanted to show you that we could plot a histogram here, and we can even adjust that histogram because, you know, the freshness actually goes from 0 to 1, not from 0 to 0.8. So what we can do here is we can select edit image, and then we can say, well, we actually want that axis to go to 1. And now it goes to 1, and we have adjusted the plot. We can also add box office to the variables, and then we can explore the relationship between box office success and freshness rating. So we can go to, for instance, customizable plots. We click on scatter plots, and here we see that relationship. And if we don't want those densities, we just remove them. And if we want a linear line, we can plot it like this. We can also do statistical analysis. Obviously, the most common ones are indicated here on the ribbon. So in this case, we might want to do a regression. There are several options here. You see that we have classical options on top and then Bayesian options below as kind of an echo to remind people that when they select the classical option, they could also perhaps try the Bayesian option. And we have that for t-tests and the ANOVA and mixed models, and for regression as well. So here we're just going to do a correlation between freshness and box office success. And we see as the, you see this by eye, of course, already, that there's really not a strong linear relationship at all, and the p-value is absolutely not statistically significant. We could do a few other things as well, maybe Spearman's rho, maybe we want to have a confidence interval, and if we want to have a confidence interval from Spearman's rho, we need some bootstrapping, and that populates the table over here. Now, this is all fine, but we actually have most of the functionality in JASP is actually hidden in this modules menu. So we have a lot of great modules that you can activate when you click them. So we have a nice, I'll show you these in a moment. I want to show you audit, distributions, learn base, machine learning, maybe meta-analysis, and quality control. I could go on, they're all awesome. And you see that after I click them, they appear on the ribbon. So what are they? Well, for instance, audit presents auditors with a complete workflow. So Learn Base allows you to teach students Bayesian statistics. Machine learning covers a lot of techniques You see regression, classification, clustering, and prediction. And we have a pretty state-of-the-art meta-analysis module as well, and again, both classical and Bayesian. And recently, last week, in fact, we added quality control tools. So we have worked together with a large international company, and they wanted to use JASP, switch away from Minitab, but they needed these quality control tools. So together with them, we implemented that set of tools in JASP. What we can do, for instance, in distributions, so you can see that we actually have a ton of distributions here that you could select, both continuous and discrete. We could do normal distributions, for instance. We could play around with these settings, but we're not going to do that. We are going to select a data set to fit using this normal distribution, maybe freshness. We simply drag it in here, and we estimate parameters using maximum likelihood, which gives us the result here. And obviously we can also, if we wanted to, get a standard error of that estimate. And then we can also assess the fit of this distribution, for instance, by showing QQ plot and maybe do a KS test. Like so. There's one other feature that I want to demonstrate before we go to the interaction with R, and that is that under Preferences interface, we actually have a lot of options for languages. So it's available in English, obviously, but we have also German, Dutch, Spanish, French, Galician, Indonesian, Portuguese, and Chinese. So for instance, if I choose German, now everything here is translated to German. So everything on the ribbon, everything in the GUI, and even the output. Let's set that back to English. And this is easy to do because we've set up a nice system that makes it very easy for people to translate JASP. So our interaction with R is perhaps, well, is certainly more limited than all of the other programs. We do have an R console. So over here we have an R console, and if we open it, we can actually execute R code. I don't have time to show you this, but also we have options to filter data and to add columns. And if we do that, we can have R code as well, or we can specify a new variable, define it using a drag and drop interface. So maybe I can select.
Can we wrap it up there, EJ?
Yeah, I say one more sentence.
Sure.
With the drag and drop interface, you can, for instance, compute the log, you execute it, and then you can get the R code that corresponds to that option. And that's what I had to say about JASP. Obviously, just scratching the surface here. Thanks.
Great. Thank you very much.
And now I need to unshare my screen.
Okay, our next
there it is.
Our next presentation will be on R Analytic Flow by Ryota Suzuki. Unfortunately, he couldn't be here at the conference. Ryota is the CEO and a data analyst for EF Prime Incorporated. So he has sent us a video presentation just for this.
Introduce R Analytic Flow. R Analytic Flow is a workflow-based GUI for R. It works on Windows, Linux, and Mac. Analysis workflow is a key feature of this software. It's a visual representation of data analysis process. Each node corresponds to an operation which generates a piece of R code. For example, this sampling node is configured to do sampling of size 100. In the background, this node generates corresponding R code. Or you can manually write some code in an R script node. you can also include another script file as a node. You can run these nodes in order. If you click on this plot model node, nodes from load sample data to the selected plot model are ready to run. If you push Run Flow button, then our script corresponding to these nodes are executed. Let me show you a quick demo. Click on a data file in the Explorer and you can see the content. It's a text file, but shown like a data frame because the software detected that it's a tab-separated file. Then from the input menu, choose Read Text File operation. It automatically detects an appropriate setting and generates corresponding code. It also shows the preview of the result, which changes if you change the parameters. Then click on Run button and you can see the result as a dataframe object. Now it's shown in the R Object Explorer. Then push this Drag to Add button and drag it to the workflow. Now the node is created here. Next we'll try some graphics. Choose Quick Plot operation, which uses ggplot2. Iris is set automatically and we can set sepal length as x-axis and sepal width as y-axis. We can change the plot type or set species as a group. Then push Run to see the result and drag it to the workflow. This is how we analyze data and build a workflow. The best 3 features of this software would be the following. First, workflow visualizes the process of data analysis. It's good for trial and error and easy reuse. Second, it's designed to be interactive. Analysis GUI and File Object Explorer helps analysis, and you can try before planning the workflow. Finally, it retains the full functionality of R. You can use both GUI and R script, or you can also use R console. Main audience of this software is anyone who works on data analysis. Beginners can use GUI to work without coding or reuse workflows written by other users. Power users can write R script and visualize the process to organize their ideas, and GUI reduces the task of coding. Talking about reproducibility, our workflow is fully reusable. Parameters and scripts are saved and easily reusable. In most GUI nodes, the name of output object is set automatically, but if you manually set it, it does not change if you change the input. We have GUI operations for data processing, basic statistics, graphics, and predictive modeling. If you want something not offered, for example Bayesian statistics methods, you can write R script or make GUI with custom GUI builder. Honestly speaking, we do not have a clear plan for the future. When we started this project, there was no dplyr, RStudio, Jupyter Notebook, or GitHub. Our scripts were not really readable, and collaboration was more difficult. But the advantage of coding is greater today. If you use dplyr for data processing, the code itself would be very informative and reusable. If you push the code to GitHub, it's perfect for collaboration. Be that as it may, GUI is still a great way for data analysis. I imagine that there would be a good mix of GUI and coding and hope to find a good way. If you are interested in it, please try our analytic flow. Thank you for your time.
Thank you, Ryoto. Next up is our commander with John Fox, Professor Emeritus in the Department of Sociology at McMaster University.
Okay, I think you should be able to see my screen now. I think it's not possible, and this I'm sure is true for the other presenters, to adequately cover the R Commander in 8 minutes. So what I thought I would do would be to simply analyze in compressed form a representative problem, which is a regression problem. The R Commander is implemented as a standard R package. To bring up the GUI, you simply load the package within R. I've customized, the interface is easily customizable with various options. I've customized it here for a presentation. So for example, things are about twice as large as they would ordinarily be. And I've brought up several windows that wouldn't by default appear at the beginning of a session. The main R Commander window is here at the left. The R Commander is implemented as the standard menu dialog box interface. You can see the menus at the top and a toolbar immediately below that. Below the toolbar, there are 3 panes. One of them contains 2 tabs, an R script tab, which is essentially an R editor, and an R markdown tab, which contains R markdown that's automatically generated along with the script by the R Commander as you use the GUI. There's an output pane that shows standard R output, and a message pane that will contain things like notes, warnings, and error messages. It's also possible to open an R Markdown editor for the Markdown that's generated automatically as one proceeds. And I've shown that here on the right. And I've also automatically opened a couple of graphics windows, which would normally open as they're needed. Okay, so we need some data. The R Commander is oriented towards an active data set. One can have as many data sets as one wants open at a time, but only one is active at a given moment. We can import data from a variety of sources, but here I'm going to use a data set that's in one of the packages that's available when the R Commander starts up, which is the car data package. And the data set that I'll use for a demonstration is the Duncan data set, which contains, it's a regression data set. It's a data set that was used by the American sociologist Otis Dudley Duncan to calibrate in around 1960 the first socioeconomic status scale for occupations. Because this data set lives in an R package, there is help available for it. And you can see when I clicked on the Help on Selected Dataset button, a standard R help window opened with an explanation of the contents of the dataset. The dataset is for 45 US occupations in 1950. There are several characteristics of the occupation. As Duncan, I will focus on the income, education, and prestige levels of the occupation. And what Duncan did was a regression of prestige on income and education as a way of calibrating his occupational prestige scale. Clicking OK reads the data. You can see that now the dataset button says Duncan. We can edit the dataset or view it. Here, I'm viewing it in a spreadsheet style screen. There are only 45 occupations, so we can actually see the whole thing. And let me begin my analysis by making a couple of graphs. A nice graph to begin a regression analysis with quantitative variables is a scatter plot matrix. So I selected from the graphs menu, scatter plot matrix. I'll pick the 3 quantitative variables in the data tab. In the options tab, I'll add a least squares line and a smooth line to each panel. I already know what these data look like, so I'm automatically going to identify the three most unusual cases in each panel, and also plot concentration ellipse at the 90% level. If I click apply, the graph will appear, and I could then modify my selections, but instead I'll click OK. And then in a standard R graphics window, the scatter plot matrix appears. By default, I have non-parametric density estimates on the main diagonal and scatter plots with the concentration ellipses and the lines off the diagonal. There are three unusual cases which turn out to be significant for regression analysis of the data. I'll also make a 3D plot with education and income as the explanatory variables, prestige as the response. I'll rotate the plot automatically for 2 rotations, show a least squares surface, and identify 3 points automatically on the graph. Again, click OK. And there's the 3D dynamic plot showing the 3 problematic cases. Finally, and I recognize that I'm running out of time, I will fit a linear model to the data, regressing prestige on education and income. That model then becomes the active statistical model associated with the active data set, and I can manipulate it through the models menu. For instance, I can create added variable plots for the model, which will show me the problematic nature of the fit. And finally, if I want to modify the model, the previous selections are retained. So for instance, if you look, you'll see that minister, and I'm done, am I, Bob?
No, sorry. You got another 15 seconds. I'm not sure what's beeping.
Yeah, that was my timer, sorry. If I want to remove these 2 cases, I can type them here. Minister and conductor turned out to be problematic. And I get the model refit. To compare the models, for example, a table of their coefficients. As I said, I've simply tried to convey how one would use the R commander in a typical data analysis problem.
Great. Thank you very much, John. Okay, our next speaker is David Stern, who's a mathematical scientist and founding director at Items International.
Thank you, Bob. It's really a privilege to be here as part of this sort of panel. I really have so much respect for all the other front ends, the other GUIs. And our Instat has taken a very different path. Our Instat originated because of a need in Africa and a desire to be able to develop software in Africa which served Africa's needs. It's evolved considerably. One of the main reasons it sort of drove forward as it did is because it coincided with another need in a specific niche area related to analyzing historical climatic data. This is what I'm going to focus my talk on, because it's really what I think differentiates our Instat and can explain, I think, quite a lot of where our Instat is now. It's not, I would say, as polished as a lot of the other products are, but it is something where it's now got some steam behind it, and and is expected to really move over the next few years. So our Instat is really being driven by climatic data. And it's really come from a software which was developed in the 1980s, or started being developed in the 1980s, called Instat, a minnow of a statistics package, which got a niche area with Met Offices around the world because it had a specific tailored climatic menu. It enabled people to analyze climatic data in ways which were incomparable to sort of what would be there on a traditional statistics menu. Analyses like start of the rains, extremes, and dry water balance. These are things which can be done, of course, but they don't tend to be the priority, and you need to know the type of data you've got to be able to make these sensible. And so as late as 2020, it was still being used by national Met Offices around the world. And our Instat, which was sort of developed from, as we'll see, from 2015, it sort of started in 2015, and the climatic menu was sort of launched in 2016, was really aiming to sort of enable Instat to take the best of both worlds in terms of Instat and R. And one of the key things that I want to display this slide for is this idea of actually encouraging good statistical practice. The experience from our Instat has drawn from the long experience of Instat of trying to actually not just help people to do statistics, but it's sort of developed by statisticians with a desire to help people use better data with good statistical practice. And the WMO support on this has driven the focus on climatic and the climatic analysis as part of our Instat. So our Instat is like the other GUIs, a menu-driven front end. It's intended to be relatively easy to use for sort of spreadsheet users, a transition from a spreadsheet sheet Excel user into a statistics package. It was always intended the element of being a general statistics package for anyone working with jet data, but the climatic menu has been the driving force behind a lot of the development on our Instat. It's of course free to download and open source. One of the things which is really critical is that the spreadsheet component on the left-hand side is very similar and intended to be very much like a spreadsheet. And so you'll notice the multiple tabs. And that's a really important component, that it actually goes, it's sort of the familiarity of working across multiple tabs is important. And we'll see a bit further, linking between those tabs is an element which is maybe unique to our Instat in the way it treats multi-level data. So in this example, we actually have data at 3 different levels, at daily level, at yearly level, and that at sort of by year and month. And so the fact that these are all linked to one another, as in a database, enables us to sort of manage summaries and manage that data in a way which is a bit different to how you do your data wrangling or preparation in other packages. Very quickly, I mean, we're very much inspired by the, and so the at the heart of our Instat and the menu structure is the idea of the fact that you prepare your data, you wrangle your data, you tidy your data, you describe it, and you model it. Arguably, the menu which is best developed at the moment is the prepare menu. The other 2 menus are still sort of have substantial work which is ongoing. But the thing which really differentiates our Instat is the additional menus on specific data type. I use that word quite carefully because climatic data is specific, and we specifically focus on the analysis of historical daily data as a real priority, which many Met offices around the world need support on. I'd like to just go through a couple of examples. I'm not going to do a demo because I didn't feel the time would really allow us to get to the key points. What I'm wanting to do is to sort of explain some of the things which differentiate us. So here's an example of column summary. So we're preparing data. There's the totals. We want to get the totals from daily data. And so as part of your prepare menu, you can reshape your data. And one of the things you can do is do summaries. And we have a general summary system. We also have the column summaries. One of the things which is really important, as I mentioned, is when you do a summary, your data is then linked back to the original data. And so if you were to do more summaries, you can add them to the new data frame, which is there. And so you're not just creating new data frames, you're actually building sort of database structure across your data frames. The general menus are general for anything. There's nothing specific about this which would relate to any particular type of data. But we have a similar data sort of dialogue which relates specifically to climatic data. Now you'll notice on the left-hand side here, there's a dialogue to define climatic data, and there you provide metadata related to your data, which would enable dialogues like this to auto-populate. And that means that when you come into this dialogue with your climatic data already defined, you don't have to each time provide the sort of information. Your dialogue auto-populates.
Sorry, David.
Really
I had it muted during the 1 minute warning, so you have a one minute. Sorry.
Oh, sorry. Okay, very quickly. So the point here, which is really critical, is the same applies then for the describe. You have your general describe and then your climatic describe, and we have other instances of this. The point I really wanted to finish on is that I think that our Instat is in its early days. It's something where we have a vision for how this is going to continue. But at the heart of that vision is this realization that really statistics is still thinking about data by and large on a single data. That we work with across all sorts of topical areas is multi-level. And so the vision of our Instat is to be a statistics package which is built around multi-level data. Thank you very much.
Thank you, David. Okay, our next and final speaker, well, we've got Mike Michalki, who's going to be doing the presentation. Mike is the co-initiator and managing director of the Cultural Commons Collecting Society. And during the Q&A, we'll have Thomas Friedrichsmeyer, who is the lead developer of the Arkword project and a psychologist who works as an expert witness. I'd love to talk to you about that. It's such a fascinating career move. So, Mike, I think, are you starting out?
Yes, thank you.
Okay, thank you.
So Arkword, its first release was 20 years ago, so it's pretty old now. It was originally written by Thomas. I was not part of the founding team. I joined a few years later then. And the goal was to let R beginners do basic tasks easily, but still provide the full power of R without any limitations that you could easily get with a GUI. And also, we didn't want to offer a static selection of dialogues, but in addition to a selection of general purpose defaults, we also wanted to provide a framework so that users could add their own menus and dialogues and share these with other users. Arkword is part of the KDE project. It started on GNU Linux, but thanks to the Qt libraries that KDE is based on, there's also precompiled installers for Windows and macOS. So let's have a look. When you start Arkword, it welcomes you with this dashboard. And here you can open the recently used files, import some data, or manage your R packages, or browse the documentation. Data can also be imported from the file menu. There's an import assistant, but also dialogues for commonly used data exchange formats. So let's say we would like to import a CSV file. Many of the dialogues in Arkword have a preview of the outcome so that we can check that we've already chosen the correct CSV format before we import anything. When we hit submit in a dialog, then some feedback is added to an output file. This can be saved and reopened later. And in another tab, also a spreadsheet-like editor was opened for data frames. Here you can also quickly add new variables or rows, and it will immediately warn you if the data that you've entered doesn't fit the column type. And around the left, bottom, and right borders of the main window, there are buttons to activate and hide additional parts of Arcquad. For instance, on the left, we've now activated a workspace browser. We can see all the objects that are in the current global environment. And if you double-clicked on a data frame, it opens in a new tab for editing. So this means that you can have multiple data frames open at the same time in separate tabs. You can also browse the namespaces of all loaded packages. There's a search field for filtering, and you can quickly access the documentation for a function, for instance, if you double-click on the function name. So there's also some user-friendly dialogues for many basic types of statistical analysis, for instance, a t-test. And like I said, many of these dialogues have previews. So does this one. So you can already copy and paste the results of this table to other documents without even submitting the dialog first. Another example where these live previews are really useful is the perhaps the power analysis dialog. Dialogs also have a code preview below because they generate simple R code and Arcquad then executes it. So this allows you to study what is actually happening when you do changes to the dialog. Submitting adds the results to the active output file, and you can have multiple of these output files open also in separate tabs. So now you might notice there's this run again link below each result, and if you use this link, it reopens the dialog that was executed to get to these results with the same settings that you used. So you can re-examine what you did, do adjustments, and run the analysis again. Code from the preview below can also be copy and pasted to your own scripts. And the script editor that Arcquad provides is based on KDE's text editor Kate. It's pretty powerful and provides stuff like syntax highlighting, object name and argument completion, block selection. It highlights missing brackets. And for instance, if you are a fan of the VI text editor, it can even be configured to use VI's key bindings. Even these R scripts in Arcquad can be previewed as if you'd run them in your workspace. So you'd see in advance what would happen if you really executed this code. And of course, you can select and run blocks of your code, for instance, with the keyboard shortcut Control and Enter. And running R code then activates the R console at the bottom, which also features syntax highlighting, object name completion, and argument completion, and some other features. There's also dialogues for various plot types, for instance, box plots. Of course, plots can also be previewed, including the R code. But instead of adding it to an output file, it's perhaps more convenient to open them in their own graphics device, which has a plot history, so you can switch back and forth between plots you've made. And it can be exported directly from here into a separate file. And the export dialog then offers you some common export formats for that. There's a file browser also on the left side, which you can use to quickly open files. And for editing, this can be more comfortable, perhaps, if you use the text snippets that we provide on the right side. And there's also a preview feature for rendered R Markdown in Arcword. This is obviously not only useful for writing package vignettes, but is really boosting writing R Markdown files for me. And these rendered files can be exported as well to separate files. You can manage your R packages with Arcword, and the specialty is the checkbox on the top. If you check it, it will list only packages that provide an extension to Arcword. This can be ordinary packages you can use without Arcword, or plugin packages that only contain a dialog for Arcword. And if you install it, Arcword will immediately use the plugin, and you have new dialogues. You can also add your own dialogues to Arcword, and one way to do this is the Arcword dev package. It lets you design a new dialog in an R script, and if you run the script, Arcword immediately detects the new plugin, and there it is, the results of a few lines of R code. And by the way, the main view window can be split and tiled to as much as your monitor can hold. And the last feature that I would like to show is the Git integration. So there's a Git part on the left-hand side. It lists all modified files. It shows a diff if you click on the file, and you can stage commit and pull and push whatever you like. And that's all the time that we have.
Thanks very much, Mike. So we ran into a delay in the beginning with the start of the broadcast. So we've run into the official end of the Q&A part, but we have a half an hour before the next session. I'm happy to hang around for as long as people have questions. And we do have, let's see, we have a couple answered already, but we've got a good one here from Joel Cheney. Says, hi all, which of these GUIs can be server hosted and which can be used to read or write data or analysis results shared by multiple end users? Who wants to dive in here on that one?
Jamobi can run on the server. So again, that's what we've got, the Docker container sort of thing, and so you can either use the public cloud version we run, or you can run it on your own server. And of course, you can access it using the web browser and everything like that. At the moment, we don't have good file syncing and sharing from the server-based version. So one of the obvious, that's obviously the huge benefit of a web-based version is that you could just send someone a link. Yeah, but that's where we're headed anyway. So,
okay, thanks.
Yeah.
Let's see, is JASP available in a server version?
Absolutely not at the moment. We are frying some bigger fish first. The web version is actually, since the very early stages, it has been on the back of our minds. But look, compared to all the other programs, it's clear that our integration with R is not as good. And this is something that's our primary objective. And we've worked for a long time, very hard behind the scenes on this. And we have some stuff working in development that I'm really enthusiastic about, but we need to fix that first before we start thinking web versions.
So are you able to display the R code yet? That was one of the odd things about JASP, I believe, for at least for a while.
Yeah, right. So that's exactly what we need to do. Yeah.
Yeah. Okay. So are any of the other teams working on a server version?
Bob, I just jumped in. So a server version can mean a couple of things. It could mean, it could mean a client on a client machine that's connecting to the server, and all the processing happens on the server. It could mean, a web UI as well, as Jonathan spoke about. It could mean also running the existing desktop clients on a Citrix or a terminal server as well, or Dockerizing it in containers. So I'm not 100% sure. I may have missed the earlier question, But when we talk about server version, what are they asking for?
Yeah, so I'm under the impression anything that runs on Windows could be running on a Windows server and displaying through MetaFrame or some software like that. So I'm assuming they're talking about some kind of via a web interface. Does that seem like a safe assumption?
Can we get that clarified? Is it do they want a server for just computing large data sets? That's a slightly different problem.
Yeah. I don't really know. So
Okay.
let's see. That's the only question. Oh, go ahead, Thomas.
Maybe I would just jump in. Maybe I'm misinterpreting the question too, but one way to look at it might be can the program be replicated by others? Do I really need the same program running on my machine to do the same analysis? And well, that's actually one point which I think is important design consideration in Awkward, that we try to in the graphical dialogues we provide, we try to stay very close to plain R code. Of course, all of the GUIs that we've just seen generate R code in some form that you can take and run in plain R, but what Awkward is trying to use very few packages, to use very few special concepts to provide code that is very easily shareable and does not lock you into a particular solution. Maybe that's part of the question.
Yeah, your code is super clean. I think you're the only one that offers a choice for things like harmonic means and things that aren't available so easily through say the psych describe function or something along those lines. So your code is perhaps a little bit longer because you're putting loops around things, but on the other hand, it's extremely flexible. Okay,
so
let's see.
Bob, can I actually take Frank's question, because I'm really eager to answer
Oh, yeah.
this one?
Yeah, please dive in.
Obviously, Frank is super enthusiastic about all the Bayesian stuff in JASP because he's a Bayesian himself. But he says that won't menu-driven analyses lose steam when we have all these examples in our Markdown scripts? Well, just from my own personal experience, right? And I work in R. I'm not a good R programmer, but I do all my analyses in R. If it's implemented in JASP, I always use JASP. And why do I use JASP? Because I'm literally 100 times faster and I make 0 programming errors, right? So it's really literally the difference. If I need to do a Bayesian reanalysis, I go open, click, 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 done, right? If I need to do it in code, I need to first figure out how do I read in these data? Where are my functions? And so if you're really good, well organized, maybe you could do it. But I like to think of myself as pretty well organized, and it would take me half an hour for some of these analyses. Also, just to make a plot, a nice looking plot, right? Like you need to tinker the whole time. And so I'm 100 times faster, and that's me, and I already know R.
Yeah, David, do you want to dive in there?
Yeah, I think this is a really good point, and I basically agree totally that we had a training where, as I said, our Instat was originally designed particularly for Africa. It was designed in Africa for Africa, but it was our thinking really changed when it was used at a European meta-agency group for analysis of climatic data, where they were comparing satellite data to station data. And of the audience, most people were R users and 2 people were really good R users. In that workshop, by the end, the 2 really good R users were still using R over our Instat, and they complained that they were so much slower than everyone else. Exactly what, and they couldn't get as far. They just couldn't do as much. So my prediction actually goes the other way. Once the GUIs actually really advance further and really take the analyses and actually are able to do this much better, actually more and more people will be using and learning to code through the GUIs, and will be integrating GUIs into the coding. It's this integration of the power of being able to code with the speed of being able to do things through a good GUI that will actually make the real progress in the future. That's my prediction.
Thanks, John.
Yeah, I in contrast am less, hi Frank, by the way. I'm less enthusiastic about GUIs for more advanced users. I originally designed the R Commander to be used in teaching basic statistics classes as a way of preventing students from getting bogged down in the details of producing code, as opposed to concentrating on the statistical ideas. And I mean, I still think that's a reasonable role for GUIs. And perhaps even in a second statistics class, like a regression class, one could make an argument for that as well. But more generally, I think after a certain point, users are better served by learning to and I think that they gain much more flexibility. May take them a little more time, but thinking about what they're doing is probably not that bad an idea. GUIs can, I think, force people into a sort of Procrustean bed of what has been provided, rather than providing the kind of flexibility one gets at the command line. I mean, I recognize that there are arguments about occasional use and use by unsophisticated users and so forth. So I wouldn't like to make this argument in too extreme a form. But in general, I think after a certain point, people are better served by using something like RStudio, writing commands and scripts and markdown documents within RStudio, for example, and using a GUI.
Aaron, you want to comment?
Yeah, and this is the reason why we try to do both. Provide a powerful GUI and provide an IDE. The IDE in Blue Sky Statistics can't match RStudio, but we can get pretty close. I'm excited to see what we're able to do here with that, in the product, with that GUI and the ability to just copy and paste code from wherever you want to create new script files and run it, and more importantly, see nice output. That is where the challenge is, intercepting those objects and showing it. But I think I think someone is going to do both. We're doing it, and I bet you all will also be forced into doing that, marrying both into one.
Okay. So there are no more questions that have come in, but I happen to have a few myself.
I think I accidentally answered a question in text, but it was for all panelists, so it disappeared.
Do you want to, can you just say what it was and how you answered it?
Yeah, it was by Ross, and he asked, what is the single most exciting, important addition you will be adding in the future? And
excellent question.
I can give you my answer, and Thomas will already know what I say. For me personally, it's that the next version of Arcwood can simply restart the R backend, so you have a fresh R session without restarting Arcwood. That was something that bugged me for years when I was developing R packages. That in order to check out whether the changes that I made are actually working now, I always had to restart the application because it wouldn't unload cleanly.
I do that in RStudio pretty frequently.
Mm-hmm.
So do we want to just answer that question from left to right, top to bottom? So David?
For me, the most exciting thing that we're looking at going forward is working with multi-level data in a more integrated way. Your preparation step, your wrangling is totally transformed, and the way you do multi-level analysis can be transformed.
When you say multi-level, do you mean like hierarchical, like aggregated at different levels?
It could be aggregated. Okay. It could just be household surveys, which are at the household at the end.
Yeah.
There's many different sorts of ways you get hierarchical data or multi-level data.
Yeah, okay, that's what I thought you meant. I just wanted to clarify that. Okay, John?
I'm sorry.
Yeah, I'm sorry. Did you?
John Fox, sorry.
I don't have any really exciting plans for the next version of the R Commander. What comes closest is some more 3D graphics. So I've added 3D component plus residual and added variable plots, which I guess are more statistically exciting than they are interface exciting.
Okay, Thomas?
Well, Mike has already said something. I think.
Oh, yeah, sorry.
I take the opportunity to add another thing. I think one rather significant addition will be that we're hugely expanding what we provide for snippets. This is going to make it very, very much easier to write R scripts, to write R Markdown, to write even LaTeX. So I think that's a small but significant addition.
Okay. Eric Jan?
Well,
Sorry,
I already. Oh, sorry, Jonathan.
Oh.
Jonathan, go ahead.
Bob, did you say left or right? Because I think mine might not be in exactly the same order as yours.
I think
Oh.
Yeah, okay. But sorry, apparently EJ sticks.
No, Jonathan.
That everyone could be seeing something different.
We're really concentrated on the web-based version. So again, making it really easy to be able to just send links to colleagues, and that's what's lubricating that sort of collaboration. That's really a big emphasis for us. So yeah, and that's the stuff I get pretty excited about as well. So yeah.
Okay. All right. So now I'm really confused. So EJ, you haven't said.
Well, so I already alluded to the fact that we're playing catch up with respect to the R integration. That's our primary objective. So I hope that by the end of the year, we'll actually have a really close integration with R, so that we're actually somewhat on par with what everybody else is doing. I think that's the most important thing. And we have a ton of other ideas that I'm really excited about, but they're a little further removed from the goal of this meeting, I think. So.
Okay. All right. And Aaron?
So we've got a couple of capabilities that we're ready to release very soon. One is the extensibility framework that allows someone to create new dialogues. On that theme of collaboration, we want to release a dialogue editor, so a GUI for creating custom dialogues and just integrating and sharing it on the marketplace. We hope to be there in a couple of months. We've also got design of experiments and Six Sigma capabilities that are pretty much done. We've just not released it yet. We're waiting on feedback from a couple of people. And then beyond that, I think reproducibility is key. You've seen some of it already, but we want to make that more robust. Bayesian statistics, SCM, and mixed model improvements on top of the chart. But within 2 months, we've got to get out the extensibility framework and the work we've done on design of experiments and Six Sigma.
Okay. So let's see. So no other incoming questions. So a question I have is, one of the features that I certainly appreciate when I've got it is a table of contents when I've got a lot of output, being able to quickly jump directly to a specific piece of output. And I believe only JASP and Awkward have that at the moment. Have any of the others thought about adding that?
Yes.
And any time frame on that?
I don't know. I think a few months. I think a few months.
Okay.
Probably at least a year.
And somebody else?
So yeah,
okay.
Probably at least a year first.
I hadn't actually thought about it, Bob, but it's an interesting thing to look into. The R Commander, I think, as you know, generates Markdown and LaTeX documents. And
and Markdown has a great ability to generate its own table of contents.
LaTeX, it just requires that I create more structured Markdown in LaTeX. And I'll look into it. I think it should be doable.
Okay.
Yeah, I wasn't able to demonstrate that because the time was,
Sure.
was rather
Sure.
sparse. But the Markdown editor allows you to type, arbitrary text in between the code blocks that it's generating, and press a button, and you can get a document in HTML or Word or PDF and so on.
Sure. Sure.
And there's no reason, I think, that document couldn't be more structured. Yeah, that's a good suggestion.
Okay. So a feature that was in SAS and SPSS back in the 70s, and probably in R as well, was group by kinds of a capability to whatever it is, whatever graph you're making, whatever analysis you're doing. There's this one analysis we do at UT where we're doing a linear regression to see what predicts salary within a department, and we're basically looking to not have sex as a significant factor there. So we're basically doing the same regression 250 times. But when it comes to group by, I think Blue Sky is the only one that does it, and that really surprises me. I would have expected you guys to all to have added that as one of the first things. Any plans?
I do have a kick-ass implementation in my mind. I know exactly what I want it to look like, and I know exactly how I want it to behave. But the code hasn't hit the code editor yet, so we're not quite there yet. But yeah.
Devil's in the details, huh?
Yeah. So.
Other.
We've exactly got into the details on one occasion and decided that this is something we definitely are intending to do it, but you can't do it halfway because there's so many different ways you should do that. I mean, just sticking a loop around everything's relatively easy, but that's not the right way of doing it. And so actually to get the devil's in the details for how this would be integrated across all this sort of software, and we will do it, but it's not happening yet. It will happen in the next couple of years.
So some of the R-Commander dialogues will do that. But I think the general structure of the R-Commander, particularly for statistical models, would make that unnatural, in that when you have a statistical model, you can have many, but one of them is active, and you can interact with the active model. Now, if I fit 10 parallel models, which is the active model, it's not really what the GUI is designed for. It's really designed for interrogating a particular statistical model at a time.
Okay.
Yeah, we also have it in just a very select few dialogues. And it's certainly one of the things that I always intended to add. If you're looking back at 20 years of our history, it's certainly that the project went a rather different path than I imagined at first, and it's certainly gone more into the IDE direction than I used to think. But some of those basic group by data wrangling capabilities is something that I always have at the back of my head, but I'm afraid any time frame that I'm going to give is going to be a lie.
Okay, thanks. Mike?
Yeah, I want to add something more generally for project. As I said, that we don't try to think for the users what they would like to have so much. So the dialogues that you see, most of them are really written by people who wanted them or who asked for them, and then we implemented them. So if you wrote a bug report and asked us to add this specific feature, then chances are that at some point Arcot will really have it. So for instance, I wanted item response theory in a GUI years ago, and that was my first plugin for Arcot. So Arcot comes with a full range of rush model fitting, and so on, which is rather exotic, but that's the way that we drive the dialogue development.
Yeah,
users have to ask for it.
We get feature requests for IRT models as well, actually.
For what model? Oh, IRT models.
IRT, yeah.
Yeah, and I guess Blue Sky has got IRT. Has it made it into the new version, Aaron? Item response theory.
So sorry, I was talking on mute. No, it's not in the new version, but it is in the old version. And I think Lasonis has got a book on it as well, if I'm not making.
Yeah, I've seen that book.
I can't pronounce his name to save myself.
I think you got it.
Jamovi has the Snow IRT module. That's fun.
Ah, okay, thanks. Okay, so there's a Jamovi feature that I'm a big fan of. Such a simple thing to bring up a dialog box, and you've got a bunch of messy variable names and lots of them that you can specify a search string. Do I have it right? Is that Jamovi?
Yep. Sounds like us.
Okay. All right. All the rest of you guys, please add that.
In the R commander, you can search the first letter of the.
Oh, okay.
You click
a lot of times that really would help.
Yeah. You might have noticed I went right to the Duncan data set. I pressed the letter D.
Ah, okay.
Yeah, and that's true in every list box.
Oh, nice. All right.
And has been there for 20 years.
Oh, great. Let's see, where am I? Oh, filtering.
Are there actually still people in this session, or is it just us talking at the moment? Which I like. It just seems that there's so few questions.
Yeah, there are hardly any questions. There are 16 people still here.
Good. So
that probably includes us. So we're a third of the audience almost. Or
anyway. What is the number next to the panel discussion?
103.
There's a 103.
Oh, where is that?
To the right of the panel discussion, graphical user interfaces for R.
Panel discussion.
We are asked to bring this session to an end.
Oh, are we? I'm not seeing that. All right. Well, we covered a lot of territory, and let me say it's been a thrill for me to see all of you. I've emailed back and forth with some of you people for I don't know, 20 years just about probably, and I really appreciate when I write a review. I hate to be critical of all the hard work you guys have done, but you almost all have been so nice about, getting back and adding things to your list of things to do. And so anyway, I very much appreciate all the work you guys have done, and I've enjoyed all of your products.
Frank has another question that he just asked.
Here we go. I only noticed a non-trivial regression specification in R Commander. Do other GUIs plan to offer that, e.g. natural splines? One of Frank's favorite topics. How about that? So I have seen, by the way, I noticed that in fact, I think I was talking to Aaron the other day, that the dialogue, the model builder for Blue Sky does a lot of things, automated two-way or three-way interactions and so forth, but I believe it was missing splines. Is that Blue Sky?
Yeah, it's easy for us to add, Bob. I can make that available.
Does anyone else have that in their model builder? I really don't know offhand.
Yeah, the R Commander does, but Frank.
Yep.
Okay, good.
Well, in our machine learning module, we have, of course, all sorts of, non-standard ways of doing regression type models.
Mm-hmm. Okay.
Boosting decision tree, k-nearest neighbors, neural network, random forest, regularized linear and support vector machine, but maybe that's not what Frank was.
Yeah, I don't think that's what Frank means. I mean, those are a lot, the standard machine learning things, but I think Frank's pretty into splines and things closely related to that.
Yeah, I'm not sure we have that actually. I'll make a note.
Okay. All right. Well, thank you very much for participating.
Thanks for organizing this, Bob.
Thanks,
You're,
Bob.
you're
and
most welcome.
Thanks, everyone.
Cheers.
Thanks, everybody.
Bob.
Bye-bye.
Bye.